Hello everyone. In this video we're doing activity 7.2, which is an independent measures t-test, and we're doing it in jamovi. Right. Now in this study we have two separate groups. It's an independent measures design, and the two groups are asked different questions about how long do they think the Nile River is. Right. So one group is first asked, do you think that the Nile River is longer than 800 miles long? And then they're asked, well, how long do you think it is? So we have each person's estimate for how long they think the Nile River is here in this second column. The second group is asked, well, do you think that the Nile is longer than 3,000 miles long? And then after that, they're asked, well, how long do you think it is? Okay. And then we record their estimate. Okay. So we have estimates from 22 different people here. Now, right now, our groups are just labeled as groups 1 and 2, and it's helpful to rename those in ways that make a little bit more sense. Right? So we have two groups, and our first group was given a low anchor. The low anchor was 800 miles. They're asked, is the river greater than 800 miles long? Our second group we're calling the high anchor group, and they're asked whether or not the Nile is greater than 3,000 miles long. And so what we're testing here is whether or not asking this question with a relatively low number or a high number affects how people answer the question for how long the Nile actually is. So we're going to do an independent measures t-test. So you click on t-test and independent samples t. Now we only have two variables in this data file. Our dependent variable is people's estimate for how long the Nile is, and then our independent variable in this study is our grouping variable, which we've just called group, which group they're in. They're either in the low anchor or the high anchor group. Okay. So we're going to look at mean differences and get confidence intervals, effect size with confidence intervals around those, descriptives, and descriptive plots. Now, before we interpret any of these statistics, we first need to look at this homogeneity test. This is a test of the assumption of homogeneity of variance. Right? And what that test is looking at is the two standard deviations between the two groups. Right? One assumption of the independent t-test is that those two standard deviations are both estimating the same population parameter. Right? Because later, to do the statistics, the computer is pooling them or averaging those two standard deviations. That really only makes sense if they're actually estimating that same population value. So as a general ballpark, if one of those standard deviations is much larger than the other, then you start to be concerned that you have a possible violation of that assumption. And by much larger, we usually say like 3 times as large. Right? In this case, one group does have a much larger standard deviation than the other group. So we're going to look at the homogeneity of variance test, which is Levene's test, which gives us a p-value of 0.003. And that tells us that that difference we're observing between those two standard deviations is probably a real difference. It's probably not simply due to sampling error, which in this case means those two standard deviations aren't representing the same population standard deviation. So when that's the case, rather than do the student's t-test over here, you click on the Welch's t-test. Right? And this does some different calculations for the degrees of freedom. Right? So we're going to be interpreting the Welch's t-test here. Right? So what we're doing with this t-test is comparing two means. Our low anchor group, on average, said that the Nile was about 1,281 miles long, whereas the high anchor group said it was on average 3,199.9 miles long. So our t-test is meant to compare those two means and see if that difference is large enough for us to think that it's not likely to be due to sampling error. So we have a t-statistic here of negative 3.42. And the reason it's negative is that the computer did low minus high, which gave a negative t. If you had done high minus low, it would have given a positive t. Our p-value there is 0.005, which tells us that there's a small probability that the difference we're observing between our two means is likely to be due to sampling error. Right? This is strong evidence against the null hypothesis that those two means are actually equal to each other. Right? The mean difference we're looking at here is negative 19.1873. Right? And that difference is unlikely to be due sampling error. It's not really zero in the population is what we think. You'll notice here that the degrees of freedom are a decimal. We're not going to go over in this video how those are computed. You can look in the book for information about that. But when you report the degrees of freedom with the Welch's T, they're going to be usually a decimal. Next, we have the standard error of the mean difference, followed by the 95% confidence interval around the mean difference. Right? So we can be 95% sure that the true difference between the means in the population is somewhere between negative 3,145 and negative 692. Right? We're 95% sure that the true value in raw score units is there. Right? Now you'll notice for our effect size is very large, negative 1.46. Remember with effect sizes, we ignore the negative sign just to determine how large it is. So 1.46 is a very big effect. But note that we don't have confidence intervals listed there. To get the confidence intervals, you need to click back on the student t-test. And it's fine to use these for the confidence intervals around our effect size. So we're 95% sure that the true effect size is somewhere between negative 2.48, which is really big, and negative 0.39, which is small to medium in size. Right? That's a really large range of values for our confidence interval. And that's because one, the standard error is really high, but also our sample sizes were really small. We only had 11 people per group. Right? So it does look like there's a difference between these two groups. We have a low p-value. The difference is probably not due to sampling error, but we should be very cautious in interpreting results with this small of a sample size, right? Especially with a study where, in this case, it would have been really easy to collect more data and have a bigger sample size when doing this. If you scroll down, you can also see plots here showing the two groups, means and medians and variability. Okay. All right, and that is all you need to do activity 7.2.